Let's solve this system by Gauss Jordan method. So first, I'm going to write down the augmented matrix. We write this augmented matrix by taking only the coefficients of the variables and the constant. So from the first equation, I write down the coefficients of x and y as like this, that is 2, 4, and then the constant is -6. And down below this, I write down the for the second equation, that is -3, -5, and +12. I also put a vertical line and then enclose this in matrix format. So let's start to do the row operation so that we have to make these diagonal elements as 1. So this has to be made as 1, and then the other elements has to be made as 0. So this has to be 0 as well as these two elements has to be 0. So first I'm going to do this operation. That is, I divide this row 1 element by 2. So this is updated to row 1. So we have this row 1 elements, that is 2, 4, -6. And if you divide all the elements by 2, we'll get 2 divided by 2 is 1, 4 divided by 2 is 2, and then -6 divided by 2 is -3. So this is the updated row 1 elements. Let's write down here. So it becomes 1, 2, -3, and we write the row 2 elements as it is, that is -3, -5, and then +12. We now do this row operation. That is, I'm going to multiply the row 1 elements by 3, that is 3 or 1, and add with row 2 elements. So this is updated as row 2. So let me do it here. I have to multiply this row 1 elements by 3. So 3 times of 1 is 3, 3 times of 2 is 6, and 3 times of -3 is -9. And add with the row 2 elements. So I write down the row 2 elements down below this, that is -3, -5, and +12. Now we add these two together. 3 -3 is 0, 6 -5 is +1, and 12 plus -9, and this equals 3. So this is the updated row 2 elements. So I write down the row 1 elements as it is, that is 1, 2, -3, and the row 2 elements as we have done here, that is 0, 1, and 3. So now we can see that we made this diagonal elements as 1, and also these two elements, one of the other non-diagonal elements is already made 0, except this element, that is the element 2. So let's do this operation. That is, I'm going to do row 2 multiplied by -2 plus I add it with the row 1 elements. So this is updated as row 1. So I'm going to multiply the row 2 element by -2. That is, 0 times of -2 is 0, and 1 times of -2 is -2, and 3 times of -2 is -6. Then I add with the row 1 element. So I put this row 1 element, that is 1, 2, -3. Now add this together. 0 plus 1 is 1, 2, -2 is 0, and -3, -6 is -9. So this is the updated row 1 element. Let's write down here. So therefore it becomes 1, 0, -9, and then the row 2 elements is 0, 1, and 3. So this is the updated matrix or the system. Now you can clearly see that we made this diagonal elements. This diagonal elements are already 0, and the non-diagonal elements, I'm sorry, the diagonal elements are 1, and the non-diagonal elements are 0. So we end up with the final stage of this row operation. So we can transform this to the system, that is 1 dot x plus 0 dot y equals -9, and for the second equation, that is 0 dot x plus 1 dot y, this equals 3. So this is equivalent to 1 dot x is x, 0 dot y is 0. So x equal to negative 9. And this implies 0 dot x is 0 and 1 dot y is y. So y equals 3. So we found the solution to the system, that is x equals negative 9 and y equals positive 3. Let's solve this system in question 7. So first let me write the augmented matrix, that is 2, 4 and negative 6. This is from equation 1, and from equation 2 I write down 1, 2 and negative 3. I put this vertical line to separate the values of coefficients and constants. So once again I do this operation, that is row 1 divided by 2. This is updated as row 1. So I'm going to divide all the elements of row 1 by 2. So when I do that, 2 by 2 is 1, 4 divided by 2 is 2, and then negative 6 divided by 3 is negative 3. And then I write down the row 2 elements as it is, that is 1, 2, negative 3. Now I do this operation, that is R2 minus of R1. This is updated as R2. So I write down this first row elements as it is, that is 1, 2, negative 3, and then R2 minus R1. So 1 minus 1 is 0, 2 minus 2 is 0, negative 3 and negative of minus negative 3, which is negative 3 plus 3 is also 0. So we now end up with this matrix or the system equivalent. If you look at the second row, this is equivalent to 0 dot x plus 0 dot y, and this equals 0. Clearly, no value of x and y can satisfy this. I'm sorry, all the values, it has many values of x and y which will satisfy this equation. Even if you put, let's for example, if you put x is x comma y is 2 comma 3, this will satisfy because 2 times of 0 plus 3 times of 0 equals 0. And even if you put negative 1 on the negative 2, it's still going to satisfy this equation. So we see that this system has infinitely many solutions. This is infinitely many solutions. Let's solve this system now. So first let me write the augmented matrix, that is 2, 4 and negative 6. This is from equation 1, and from equation 2 it is 1, 2, 1. Now once again I do this row operation, that is row 1 element divide by 2. This is updated as row 1. So this gives 1, 2, negative 3. And I write the row 2 elements as it is, that is 1, 2, 1. Now I do this operation, that is row 2 element negative row 1 element, and this is updated to row 2. So we have to subtract row 2 elements uh, from row 1 elements. This 1 minus 1 will become 0. So I write down this row 1 elements as it is. This is 1, 2, negative 3. And this is 1 minus 1. We have to subtract like this. 1 minus 1 is 0. 2 minus 2 is 0. And 1 minus of minus 3. And this equals 1 plus 3, which equals 4. So here we get 4. So this is the updated matrix. Now we can transform this second row in in equation form. That is, it translates to 0 dot x plus 0 dot y, and this equals 4. We can clearly see that no value of x and y can satisfy this equation. Say, for example, suppose we plug in the pair x equal to 1 and y equal to 2. This will become 0 dot 1 plus 0 dot 2, and this equals 4. That is, 0 dot 1 is 0 and 0 dot 2 is 0. This equals 4. So this implies 0 equals 4. So this is not true, and this means it does not satisfy this ordered pair. So likewise, even if we put any ordered pair, it's not going to satisfy this equation. because we end up with this situation that is 0 equals 4, which is not true. So we say that this system has no solutions.